The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, everybody, and welcome along to DBA Fundamentals, this second edition for September. My name's Warwick Rudd, and I'm your host for this session today. We have got everybody streaming in at the moment. So for all of you, this session is being recorded, and I will hand over to Kimberly, who will talk to us about stored procedure optimization techniques in a minute. I do have just some housekeeping to run through before we start. So first off, a big thank you to our sponsors. Without our sponsors, it makes it very difficult for us to put these sessions on for you so that you are able to continue your learning. But for those of you who haven't been to SentryOne's website, make sure you do. They have some fantastic materials that are free for you to download, trial and use that can assist you with your day-to-day work activities, but also your ongoing data platform learnings. A big thank you to our second sponsor, DB Watch. Just like SentryOne, they have fantastic materials that are free for you to download, trial, and use in your day-to-day activities. For some of you, you may be aware, but we have Ignite coming up, and we're just doing a call out for Bob Ward, who is doing a session on October 14. So make sure that you register at aka MS Azure SQL Digital Event, and you can learn from Bob Ward, which will be a fantastic session. Now, just like this virtual chapter, there are many virtual chapters out there available from PASS. Make sure you go along, have a look at what each of those are that may pique your interest. Register for those, just like the DBA Fundamentals virtual chapter. Get notifications about the sessions and broaden your horizon as a data platform professional. So with that, we'll hand over to Kimberly for today's session.
Okay, well, thank you. This is great. I just want to make sure that I'm getting the right screen. I've got 3 monitors here. There we go. So that should be on air. How's that looking? Is everything good there?
Yes, we've got your slide deck.
Okay, so I am going to try to keep this to about an hour, maybe 65 minutes or so. I know that a lot of you are taking your lunch hour or evening time or, personal time to actually watch this presentation. So I want to make sure that it's really valuable for you. I have a couple of housekeeping slides as well. I'm going to blast through these quickly, but I am going to bundle up all of these slides and all of my demo scripts and all the resources and even some extra links that I think are helpful to you to look at after the event. And I will pass these all on so that Warwick can put these up on the DBA Fundamentals kind of central resource location that I know you guys all know how to access. So I'm just going to kind of cruise through these very quickly. As far as, let me see if my clicker's working. As far as SQL skills, we're a group of folks focused solely on SQL Server. So that tends to be, what we do day in, day out. And we all have different areas of expertise, which is also really nice. And some of you see us on Twitter and blogs and so forth. We do training in person, but obviously these days it's online and virtual. We also have recorded training on Pluralsight. We do health checks and all that good stuff. We also, probably the coolest thing is at the bottom of the slide, we have an insider newsletter that only comes out twice a month. We don't spam you with tons of, marketing emails. It's literally just our newsletter that gives you some insight into upcoming events, but also there's a video in it every 2 weeks. There's Paul's ponderings, as we call it. There's a curious case, something that we've seen at a client. So there's some cool stuff on our insider newsletter, so you might want to consider joining that. Pluralsight, if you don't have any form of access to Pluralsight, you should check it out, and you can email Paul at sqlskills.com, and just put something like Pluralsight code in the email, and he will send you a code that will give you 30 days of access to all of our SQL Skills content. And there's actually a ton of additional content on some of the stuff we're talking about tonight. So some of you might end up, if you really want to dive in to a lot more options and, you know, different types of problems than just the one we're going to talk about tonight, you might end up wanting to watch the stored procedure courses. One of the cool things, I can't even believe that this is the case, but I started SQL Skills 25 years ago this year, so 1995, and we are celebrating that. We just introduced badging for our courses, and we've got some virtual courses running in September and October, and we've got a 25% off discount that you guys can access if you're interested. So just check all of this stuff out, and I will leave all the marketing stuff for you guys to look at after you get the slide deck. My background with SQL Server is that I tend to focus on architecture, VLDBs, so large databases, large tables, and the problems that are associated with those things. Some of those things that come along with size being problematic are things like maintenance, storage, archiving, and of course, performance, right? So there's a lot of different aspects to kind of how we deal with these very large structures. So that tends to be my area. And my favorite things are partitioning, indexing, statistics, and ironically, stored procedures. And a lot of people kind of go, well, that doesn't make sense. Well, you're talking about architecture and indexing and statistics. Why are stored procedures so interesting to you? And I have to tell you that as much consulting as I do on architecture, I have never, ever seen a client that did not have misunderstandings or just assumptions that they have made about SQL Server, not because they're dumb and not because of the breakdown of assumption. I'm not even going to go there. It's not that. It's that there's unintuitive behaviors around stored procedures in SQL Server. And so, as I was saying, I've never seen a customer that did not have the problems that I'm going to describe this evening, right? And, well, it's evening for me. So I think as much as you might do in terms of architecting a table, creating the right indexes, making sure that you have not only up-to-date and accurate statistics, possibly filtered statistics with some of these large objects, even partitioned tables may benefit significantly from things like filtered stats. But here's the real crux of the matter. You could do all these things architecturally, and if your stored procedures are not compiling when they need to, and using cache plans only when those plans are truly stable and consistent, I promise you, you're going to have tons of weird, intermittent, difficult to troubleshoot performance problems where sometimes a stored procedure may appear to be working correctly, it might appear to be fast, but then occasionally it seems almost to fall off a cliff, the performance is terrible, maybe somebody even looks at the plan of the stored procedure and they're like, oh my gosh, look at this, the estimate is way off from the actual, what should I do? Oh, it's those darn statistics again. So then they go and they update the statistics, they rerun that stored procedure and they get better performance, and they just had a false positive. The false positive was that it wasn't actually the updating statistics that gave them the benefit. It was this thing that happens when you update statistics at the end of updating statistics that was beneficial, and that was the invalidation of the plans. Statistics get blamed, and then indexing, not using the right indexes, or maybe somebody complaining that the performance is bad because, you know, we don't have the right indexes, or SQL's not using the indexes. Why is SQL Server so stupid? Like, all these things are said about stored procedures and about plan caching. And what it really is just a fundamental misunderstanding of how stored procedure caching works and this very, very common problem called parameter sensitivity. So in all my years, this is probably one of the most common problems that even when we architect correctly, when we create the right indexes, when we have good statistics, we still subsequently have performance problems if we don't also write effective code. So this is why I love this talk. So that's kind of my overview, but what we're going to talk specifically to during the session is how stored procedures are processed, how stored procedures are optimized, And then to keep us on track, I actually have a whole bunch of additional extra hidden slides that you guys can go to that give you even deeper information on plan invalidation and caching. But I'm going to spend most of my time in demos around plan quality and problems with procedure plans. But most importantly, I'm going to tell you why recompilation is not a bad word. Don't get me wrong. I don't want you to recompile all the time, because over recompiling or recompiling too often or smacking the option recompile clause onto all of your statements and all of your code, that becomes a problem too, where you're going to be wasting CPU. So we've got to really figure out when we should recompile and how to effectively and only recompile when it's truly warranted. So we've got to be careful. There isn't just one way to write code. We don't never use option recompile, and we don't always use recompile, okay? We have to figure out how to deal with our code more conditionally, more logically, and more tied to the data patterns and the behaviors of that code. And all of this sounds really difficult, and sometimes I'll lose people at this point thinking, oh, this is just way too complicated. SQL Server should be doing all this stuff for me. And SQL Server does do a lot of stuff for you, but it also is so big in terms of the number of features and the functionality that there isn't always one good way to do everything. And this is where I think people struggle. They hear that SQL Server has an optimizer. They hear that SQL Server creates indexes for you, like on primary keys and unique keys, and they start to feel that optimization is solely kind of Microsoft's deal. And unfortunately, if you don't know how to effectively write your code in your stored procedures, you can have really poor performance. And I'm going to show you some scenarios that I think will actually surprise you. So let me dive into this. And just a reminder, I always put this up to just have me double and triple remind you guys that there are a bunch of hidden slides in the presentation. So make sure you check some of those out, because they have either links to resources or details that I just don't have a tremendous amount of time to cover. But I am going to cover what I think is the most important. So processing of stored procedures. When you guys create a stored procedure, not much actually happens. They basically just check the code, make sure that's syntactically correct, and they put essentially the code into a bunch of system tables. You don't access those system tables directly, but when you execute or when you say, hey, what does the code look like? Maybe you do that in Management Studio, where you want to view the creation code of a stored procedure. What's really happening behind the scenes is they're going to these catalog views and stored procedures and doing things like SP help text. So you can see all that information, but that's all that gets stored with a stored procedure on disk. And I can say that really is true forever, except for plan forcing. If you were to create a plan guide or forcing of plans, then plans do start to get saved with databases and so forth. But they're still not saved with the object itself. It's more of a reference that SQL Server saves. But the long story short is, all they've done is save the code. And if you never execute, then that code just sits there and does nothing. Now, when you execute a stored procedure, something interesting happens. SQL looks at that and they say, is there an appropriate plan for this procedure in the cache? And of course, if this is the very first time you've ever executed, that will not be the case. But and this is, I always debate on how much of this tangent I want to do, but notice how I kind of highlighted that appropriate plan on the slide. What do I mean by that? Because a lot of people think a plan is a plan is a plan, and that is so not true. In fact, that is one of the frustrating aspects of troubleshooting stored procedures, is that a stored procedure could have 5, 6, 10 different plans in the cache associated with it. Those plans might be the same, they could be different. And you might wonder, why would that ever happen? Well, session settings. If different users are connecting from different applications, or even the same application where the session settings have been changed, then they will not be able to share those plans. Not all session settings affect plans, but it is very important, and it's very, very difficult from a troubleshooting perspective to figure out sometimes why user in application X runs something that's, let's say, fast and efficient, but another user runs that same thing and maybe even in the same application, but for some reason it's slow, and maybe it's even returning, the same amount of data. So you even think, well, they're both returning like 5 rows. Why would one of them be fast and one of them be slow? And it could be down to something as strange as like the ODBC DSN settings, because the ODBC DSN settings affect some of your session settings. And when certain session settings are or are not set the same way, you actually will have a separate plan in the cache. I was actually going to hide this slide, but I am now unhiding this slide. So I can show you a slide, just one of the hidden slides from one of my Pluralsight courses that I spend most of my time talking specifically to troubleshooting. Let's see if it comes up. Yeah, perfect. So session settings and client connectivity. This is one of the ugliest slides I've ever created, but it's in my part 2 of optimizing store procedure performance. And I'm only mentioning this because it is amazing how many session settings actually impact your plan, and even in some cases certain features and your ability to use those features. So this slide, I'm not expecting you to digest this in the 1 or 2 minutes. I'm basically going to have this on the screen, but obviously it's one of the slides in the deck. You can spend more time looking at this. There are some session settings that are required for certain performance related features. There's some session settings that are on by default in things like Management Studio, right? But ironically, right, even though Management Studio has the right session settings that match those required for performance, it turns out SQL CMD does not. And I don't know about you, but that to a certain extent is kind of crazy, because you might have some scripts that you've written, tested, and worked with in Management Studio, but then you decide that you want to automate their execution through SQL CMD, and then you get different behaviors, right? Because you might not have the right session settings that you need to access things like index views or indexes on computed columns. Those are some of the features that have those required session settings that have to be set a certain way in order for those performance related features to actually be leveraged. So filtered indexes is a good one, computed column indexes, so indexes on computed columns. So indexed views, I'm trying to think, spatial indexes, query notifications. There's actually a bunch of stuff that when you don't have the right session settings, you might actually still be able to execute the code, but you wouldn't be able to leverage that object, that performance related object in that code. So you can have just some bizarre behaviors. And so my points, let me go back to the slide we were on. When you execute, SQL Server checks to see if there's a plan that has the right session settings for your session and is, for example, in the same resource governor group. A lot of people don't realize that that also affects plans. Each resource governor group has a separate plan cache. So you can actually clear a resource governor plan cache pool, right? But not, let's say, another resource governor plan cache pool. So you have these abilities to clear and control the resource governor pools, but that also means that the plans have to be stored per pool. So if you have 2 or 3 pools and one stored procedure is executed and there's users in each of those pools, there might be 3 plans in the cache that are the same. They could be 3 different plans in the cache. And then throw in session settings and you can have more and more and more. So it becomes challenging from a troubleshooting perspective to see all of this. I wrote a bunch of code that goes in and looks at the plan cache values, and it basically does these things to pivot the information that is in the DMVs, and will tell you all the plan attributes so that you can see for each plan what the session settings are that apply for each of those. And that's all in that troubleshooting course. So if this is something that you're really struggling with, I would definitely recommend that you learn more about how to decipher all that information that's in the DMVs and in the plan cache, because it's hugely beneficial. But why am I even talking about this? Okay, first of all, I want to stress that troubleshooting can be a challenge. But what I really want to focus on is the procedures themselves and what is in the cache, and is it good or is it not good if we are reusing it. Because if you do have a bunch of users in the same app and you're not changing a bunch of, session settings and resource governor group, which is probably the more common for most of you, then you might be reusing the same plan. And that could be good and it could be bad. So this is really what I want to stress is, when is it good? When is it bad? What do we have to be aware of here? So reusing plans can be good if different parameters don't warrant the plan changing in order to get an optimal execution. Oh, and let me just throw this out here because I didn't mention this. I do not mind if you guys want to ask questions in the chat window. I will definitely be watching the chat window, and I'll stick around for questions at the end as well. If you do type something in the chat window, I might not just stop and respond to it. I might try to integrate it into my discussion, but I just wanted to let you know to feel free to ask questions in the chat window if you do have any questions right now. So, and I think I am looking at that. Oh, there's a different questions pane. How interesting. I was looking at the chat window, and now there's a questions pane. And I see that it looks like Warwick's already been answering some of these. When to use regular indexes or when to use column store indexes. That is a great question. That's a whole discussion in and of itself. I'll give you the 3-second answer on this one. Regular or row store indexes are more for point queries, OLTP, and environments where you have a lot of modification activity and queries. Column store is more geared toward read only or read mostly, but can also be used in partitioned environments very effectively. But column store is really more for large range-based queries. So this is good. Okay, so I will look at the questions window and the chat window because I just saw a question pop up and it highlighted for me. So that's why I was able to notice that. So I'll kind of watch both of these, questions or chat. But if the questions get really long, I might end up having to hold them till the end. And I can certainly chat more about this whole column store versus row store indexes at the end too. But back to procedure caching, right? Reusing plans can be good if the plans are what I call stable. And I'm going to come back to this, and I'm going to show you, even when you have small test environments and not even super realistic data, you can still tell if your code is going to be prone to these parameter sensitivity problems that I'm both going to describe and help you solve. Now, if you do reuse a plan and that plan is optimal, that's fantastic because you save time in compilation, the plan's already in the cache, and you just kind of run with that. And that's great. I mean, when something does have a nice, clean, optimized plan that's good no matter when the parameter values change, then reusing a plan is fantastic. I'm a huge fan. The problem is, we have to know for sure that that's the case. And that's what I'm going to show you. I'm going to show you how to see this and how to get some insights in that, okay? Reusing plans, however, can be terrible. And they can be terrible when you end up reusing a plan that was good for certain parameters, but maybe isn't as optimal as the parameters, or isn't as optimal for the parameters that you're passing in now on this second or third or 10th execution. And that's what we have to get some insight into. And the good news is, I'm going to show you a way that you can know very early, even when you are writing and developing the code, as to what scenarios are going to cause you this problem. So to me, it's not a matter of developers being stupid. I really want to stress this. I already told you guys that there's a lot of kind of interesting and unintuitive behaviors about stored procedures. So again, it's not that they're not smart. It's that they're not realizing kind of how SQL Server is reacting to the different types of code and the structure that they've used. So that's what I want to spend some time on. And I'm going to give you guys a great example for this. I call this an OSFA procedure or a multi-purpose procedure. OSFA meaning one size fits all. And I have a blog post. In fact, I'm going to bring that up in another window here too. I have a blog post. If you were to search high performance procedures Tripp, and I'm just doing this in another window so that I'm not bothering you guys with my stupid typing, and then I'll bring the window over once I get to the blog post. But if you bring up this blog post, I have this kind of fake widgets company. And I basically say, imagine having this dialogue right here, and you have this customer lookup, and you have decided to create this one size fits all dialogue where they can put in a customer number, they can put in a last name, they can put in a first name, they can put in a middle initial, they can put in an email, they can put in any, wild card based version of those things, and they can hit search. So you're trying to serve them like every option on the silver platter, which is a little bit crazy, but I was going to make some bad joke about users being crazy anyway, but they do tend to ask for, every possible option, and we try to give it to them. And this is just something that seems like it would be okay. So we then, behind the scenes, put together code that has, a whole bunch of parameters like customer ID, last name, first name, middle initial, email, region, and so forth. And then inside the query, we put something like where the customer ID equals the customer ID that we passed in, or maybe we didn't pass in a customer ID, so the customer ID is null. And the last name is like the last name parameter that we passed in, or maybe we didn't pass in the last name parameter. So we put in this where clause, which we think, especially from other compilers and other programming languages, that SQL Server might short circuit this and it might very optimally process this for us. And we hear that SQL Server has, a very intelligent optimizer, and I want to stress that it is incredibly complex, incredibly flexible. But what's interesting about this code is that, and interesting about how SQL Server optimizes procedures, is that they come up with a plan and they save that plan for subsequent execution. And what they're not sure of, because they don't know at this point, is how you might be executing this in the future. So to a certain extent, when you first execute it, they say, okay, this is a great plan. This might be how they're always executing it. So you know what? We're going to save this plan. Now, could they do things differently? Yes. And are they looking at a lot of things that will help change this behavior? Yes. But I still would rather get the code right rather than SQL Server having to, monitor more, track more, and then react to certain problems and try to come up with, let's say, an average plan. And we can even talk to average plan. That's another clause that you could add to this query to maybe change the way that it optimizes. But without any other clauses, like any option clauses, and I'll come back to that, I promise, right? This optimizes incredibly poorly. Okay, now some people have said to me, I don't do that, I use coalesce, or I don't do that, I use case expressions. And I want to stress that all three of these work the same way and are optimized the same way, and they all perform horribly. So let me go over to actually, let me show you a little bit more on that slide and make sure that this makes sense. So we have stored procedures with some number of parameters, and we have some, random number of those parameters that can be supplied. 1, 2, if there's 3 different parameters, then that's 7 possible combinations, essentially. So as you get to 7 or 10 or 25 different parameters, you can only imagine how many combinations would possibly exist. And having an optimized plan for each one of those combinations saved would be prohibitive. I mean, there's just no way that SQL Server could do that, especially as you get to, dozens or hundreds of parameters. So how does it do this? Like, how does it try to do this efficiently? Now, the rest of this slide is going to make a lot more sense later when you come back to reading this, because this is more of what I would recommend. But the point here is it is very hard to generalize this complicated set of different, parameters and combinations into essentially one plan that gets reused. So what happens, right? How does this work? So this is what I want to show you. I'm going to start with this kind of scenario against a database called Credit. I love Credit, even though it's an old database. It's not very exciting. It's not overly optimized, which is one of the reasons why I like it. And it is an old backup. But the coolest thing is that you guys can restore this to any version of SQL Server, essentially, that you want to play around with, because the backup that I'm going to point you to is actually a 2008 backup. I'm restoring it here, and I'll show you that I have a bunch of comments in these scripts. This is the only script you guys will need to modify, and I've put a lot of the notes here on why. This is a SQL CMD script. If I go over here, query, SQL CMD mode, a bunch, like if I deselect that, notice how a bunch of these lines kind of went to not be highlighted anymore. But if I now go back to SQL CMD mode, they're kind of highlighted with gray. So it's these lines that you guys will need to modify, because I'm not going to know where you're going to put the backup. I'm not going to know the name of your server, but I'm going to restore it to a 2019 developer instance. I don't know where your pathing is. Like on my last machine, it used to be on D, but on this machine, I have a larger drive C, and I decided to at least put my program files on C, and then a lot of my databases and so forth, at least my user databases outside of some of these test ones, end up going to D and E and so forth. But here's the benefit of SQL CMD. I can connect to a server. I can set parameters for the database. So this is really cool. It's $paren, and then that's the variable name, DB, and then end paren. So that's how you do these placeholders. So if I run this script, I'm going to restore that backup of Credit. And because it's a 2008 backup, I actually do a whole bunch of other stuff in here. I'll show you that in a second. But I restore it, and then it goes and upgrades to whatever version of SQL Server that I'm running. And then my script does a couple more kind of interesting things. At the very end, it goes and sets the compatibility level for the database. Now, this gets a little bit complicated as of 2014, actually, but I'm going to kind of expect that most of you are 2016, 17, or 19. That's where SQL Server made things better, in my opinion. But in 2016 and higher, you can set the database's compatibility level to be that version's compatibility level. So for like 2019, it's 150. But then, because this is an older database that may have been tuned for earlier versions of SQL Server, what you may end up wanting to do is have the legacy CE be set for that database. So that's actually what I do. I restore to 2019. I set the compatibility mode to 150. So I get all the optimizer hotfixes up to RTM of 2019, but I set the cardinality estimation model to be the legacy CE, so that the calculations are done based on how I've kind of optimized this older database. Now, if it's a brand new database, you wouldn't do this, but especially for older databases, then as you start to test, you can figure out when you want to move over to the new CE and then switch and turn the legacy cardinality estimation off. So at the very end of this, you can see I executed DB compat level, and you can see my database compatibility level is 150, and I didn't output the cardinality estimation model, but I have set it to legacy here. So that's what I'm doing. Now, you don't have to do this in your environment. If you want to play around with the different CE, the newer CEs up in 2014, 2016, 2017, and 2019, you can certainly do that. Pretty much everything that's in these scripts is pretty stable, and none of this stuff has radically changed across CEs. So you won't see a lot of behavioral changes in this, so it doesn't really matter for the script. Now, the way that you'll set up for this multi-purpose proc, that's the next script. So I've got a SQL Server Management Studio solution file, an SSMS SLN. In fact, what I'm going to give to you guys is going to look like this. Let me bring up another. Hold on, I lost my cursor. There it is, okay? I'm going to give you guys basically all these files that you can see on the screen here. You'll have the slide deck, and then there's the multi-purpose procs SSMS SLN. So you should be able to just open that up into Management Studio. If you guys are using a very dated version of Management Studio, you can always just go to grab the procs directly, okay? Or I should say the scripts directly. So there's the restore, and right now I'm in the setup for multi-purpose procs. Part 1, basically. So now I usually have comments. Make sure you just read the comments before you just blast through the script. You're not going to learn anything if you just run the scripts. So looking at the script and seeing what it does, I think is really useful. I have a lot of comments sometimes in my scripts. Now, this is an interesting one. I like to make the joke that developers will sometimes pull data from everywhere just so that they have more data. Not necessarily realistic data, but they might say, well, that kind of looks about right, and that kind of looks about right, and they start pulling, similar data from as many places as possible, and they might think, like in this, oh, well, we've got first names and middle initials and last names and member codes. We've got that in the AdventureWorks person address table. So person is the schema. So we've got data that looks like that over in the AdventureWorks database. Now it turns out I think I have actually a few versions of AdventureWorks here. Doesn't even matter which one, because we're just trying to grab a little bit of data. So let's see what I've got loaded on here. Yeah, I've got AdventureWorks 2012. I've got a 2008 with a modified sales key. This is one of my demo machines. I've got an AdventureWorks DW 2016. But my point is, whether you guys have AdventureWorks 2012, AdventureWorks 2014, AdventureWorks 2016, or whatever, you can pull data over from there and insert it. You don't have to do this step if you don't want to, but this is going to pull 19,000 more rows into the table, and this is going to create data that is even a little bit more disjoint. So let me explain. I'm going to keep going. The rest of this you do need to do. So, you have to do the rest of these modifications. So we're going to create an email column. Okay, so we'll execute that, and I'll kind of go through this last part a little bit faster. We'll give everybody, a goofy middle initial, which is just going to be the third character of their first name, uppercased, and if it's null, a Q, right? We're going to add a couple of rows, like a Kimberly Tripp row, a Paul S. Randall row. We're going to set everybody's email to be just a concatenated string of a bunch of garbly goop, right? So not even necessarily guaranteeing uniqueness. And then at the end of it, we're going to see that we have 10,000 original rows in credit. We just added 19,000 more. And I'm going to grab 1996, and I'm going to grab a select. And the reason why I did this is that this is often what sample data looks like. Like we've got some data that looks pretty good, right? There's addresses and stuff, but then we've got some data that looks kind of, this is all uppercase and looks like the first names are randomly generated. And then there's a bunch of not even nulls, but spaces and weird, formatting to the data and so forth. But even still, even with this gobbledygook of data, I can still see these problems if I know what to look for. And this is kind of the point I'm trying to make, is developers just don't even know they need to know this. They don't know to look for this. So here's where we're at, right? We've got sample data, not that much of it. It's not very consistent. And now we're going to start to, create some indexes, write some code. And it might even be that a lot of people, a lot of developers think, well, if we're going to put first name in where clauses, we better have an index on first name, right? And these are row-based indexes. And no, I'm not creating the indexes generally in stored procedures. Now, having said that, sometimes I do create indexes in stored procedures, but there's those indexes are permanent objects unless I'm creating indexes on temporary objects. And yes, sometimes I will actually do that in certain code, have temporary objects, indexes on those temporary objects to get better performance for the stored procedures usage of those objects, and then everything goes away at the end. So that is a strategy. But the more common strategy is to, like this, pre-create indexes that are kind of part of that database's schema, and then things like stored procedures will leverage or not these different indexes. Now, again, in this case, I'm creating indexes on the different search conditions, and I might think that this is good. It turns out that there are some uses for this strategy. It's not the worst strategy, but it's definitely not the best strategy either, because narrow indexes, indexes that have very few keys in the index's definition, and again, I'm talking about row store based indexes here, they have very limited uses. They don't have a lot of different use case scenarios. So it turns out if you start watching very narrow indexes in production, a lot of your code might not end up really benefiting from these. Sometimes they can be useful, but often they're not. But for right now, I'm going to go with this because this is very common. And I want to focus more on the procedures than the indexes. Warwick, why don't you write down a note that I need to come back for some indexing content. It's definitely another one of my favorite topics. But if we look here, I've got my OSFA procedure, and I've got a bunch of kind of reminder comments at the top. But here is my oh so clever OSFA procedure, right? My one size fits all. I'm going to go ahead and use credit. And I'm going to go ahead and drop this procedure if it exists. And then I've got my very simple procedure that has, however many input parameters. And I would usually have error handling and other things. But just for simplicity, let's say we then have our query that has all these conditions, and there's our code. So we go and we create that procedure. Just as a heads up, if you're wondering why you have the squiggly line here or why I have the squiggly line, remember that I added the email in script 1. IntelliSense for Management Studio is populated when Management Studio opens. Email did not exist when Management Studio was opened. Therefore, as long as I am in Management Studio right now, it'll never know that the email column existed. So I'll have squiggly for that everywhere. And that's just to point this out because I get that question a lot. So let's run and, oh, well, Donald, thank you. I did Control-Shift-R is I'm going to look. Control-Shift-R. I did not even know that. Oh, look at that. So you can refresh IntelliSense. See? You learn something new every day. And I have to tell you guys, this is one of the coolest things about SQL Server. I mean, I know it incredibly well. I've been doing this for a long time, but I kid you not, there will be days where someone will tell me something like that, and I'll just be like, oh, I didn't know that. When did that get added? And they'll be like, oh, that's been there since 7.0, Kimberly. So that's cool. Thank you. I might forget that, but I'm going to try to write that down and remember that one. So Control-Shift-R. And in however many sessions I've given, nobody's ever told me that too. And I have to admit, IntelliSense isn't the main thing I look for, but that's very cool. Thank you. So, all right, let's imagine we want to use this stored procedure now. Exec get member info, and I could just simply say I want to find the information for Tripp, right? And maybe I know that there might be only a couple of rows, so I don't think of this as too big of a deal. I run it. I get my one row back really quickly. I run it again with like %27.com, which is a really ugly kind of bad thing to request, but yet that comes back quickly, right? And I run it with member 9912 and that comes back quickly. Now I have to tell you, if your developer is only doing like, 3 tests like this, they're not a very good developer, okay? I mean, what I would usually do is have a script for testing each of my procedures, and I might have a whole bunch of different test scenarios, like test scenario 1, test scenario 2, test scenario 3, test scenario 4. And ideally, we'd have a script that would really push the bounds of code coverage, right? Especially if there's conditional logic, if there's, a bunch of different parameters. We might have 30 or 40 different test scenarios. We might even add to those over time, okay? So this is a much better script. But let me go back to this. Let's just say that the developer does. Maybe they even have this script. In fact, you know what? I'm just going to run this script. And I ran the script, and it's running through all my test scenarios. And check it out. It finished all my test scenarios in 4 seconds, right? Without going any further, right? Your developer might say, hey, okay, all my test scenarios work. They seem to run really fast. Let's ship it, right? And don't get me wrong, I know, and you know, that doing performance testing on a beefy development machine, like a lot of your developers have, but with very little data, is almost always going to produce this kind of behavior, even if the plans stink, right? I mean, unless they really, really, really stink, okay? But here, they're actually not good plans at all, but it's running fast enough for the amount of data that I have, because all we've done is code coverage testing, and code coverage testing isn't good enough for SQL Server database environments. And I have this term that I call plan stability testing. Now, most developers say to me, as soon as they see turn on graphical show plan, they're like, I shouldn't have to know the plans. Okay, fine. I'm not going to do that yet. Notice that's commented out. I'm just going to turn statistics IO on. I'm not going to turn time on, because time is kind of irrelevant on my machine. I mean, I have how much memory? I have 64 gig of memory, 8 cores. I've got 8 terabytes of solid state drives in this machine that is my laptop. I mean, it's ridiculous how much bad code I can write, and my machine just runs. Okay, so I'm just going to turn statistics IO on. I can't remember if I ran that. It doesn't hurt to run that again. And then I'm going to run these 3 lines again. And again, they come back quickly, right? And I might think that all is well. If I go over and look at the IOs, I see 78, 90,000, and 78. Now, you know, I think to myself, okay, 78 doesn't seem too bad, but why was this 90,000? And if I go and look at the plan, if I do turn on graphical show plan, so go up here and say, turn on graphical show plan, and I run these 3 again, you know, to be honest, they're going to be kind of misled here too. Because if I go in and look at the execution plans, I see 33, 33, 33. It seems like it did the same thing and had kind of the same cost across all of these. But this is one of the problems with these plans. These costs that they show you are the costs associated with the estimated plan, not what actually happened. Now, there is something right here, right on this screen, that does start to give you some insight that something went horribly wrong. And that's like these percentages down here. This says 1 of 2. Well, that's not too bad. This says 1 of 4. That's not too bad. This says 29,996 of 2. And it says that it's off by some ridiculous 14,000 something percent. You can't even read it here, right? So that's starting to tell you that what they expected was 2. So this 33% is tied to the 2, not the 29,996. But unfortunately, if you go in here and you look at the estimated number of rows to be read and the actual, right, number of rows, right, you start to see that we are not really right. I mean, here it does have estimated number of rows per execution, an estimated number of rows to be read, right? But the problem, right, is that on average, they're expecting 1.98, but in this particular case, we actually read 29,996, which is what resulted in this terrible number of IOs. Now, again, I'm not expecting your developers to know everything about query plans. They don't actually need to know really anything about query plans. This is really cool. One of my favorite tricks is this one. If you're in Management Studio, because this is very easy to reproduce in Management Studio. If you're in a client, you'd have to make sure that your session settings match in order to make sure that you're getting the same plan as that client environment. And there are DMVs, DM exec session, DM exec sessions, and DM exec, oh God, it was in the slides. Hold on. Not the ones, it's in some of the hidden slides that I didn't show you. So you guys can go back and look at that. But DM exec sessions, where is user process equals 1, you can end up seeing how client connections are connected and what their session settings are, so that you can mimic those in Management Studio so that you can get and use the same plan they have. So imagine that line 142 is the plan from Cache, right? And it is, let's say, the same plan that you're getting in the client application. What you can also do is execute line 145. And if I execute both of these, now notice the only difference with line 145 is this very lame, I would never recommend using this in production, but with recompile clause. And I'll explain why it's not great in a minute. Now, looking at the results, one thing might jump out at you guys, and that's that the results seem to be in different orders, which immediately tells me that the execution plan is different. But looking at the execution plan, even if you can't read the plans, you can just see that the shapes are different. That's the only thing I care about right now. So yes, the plan in cache is different from the plan that I got when I executed with recompile. Executing with recompile executes and gives that execution its own plan. It doesn't look at cache. It doesn't put this plan into cache. It doesn't touch the existing plan in cache. So it doesn't throw it out of cache. It doesn't change it. It does absolutely nothing to your existing cache. It just says, I'm not going to use that plan, and give me a plan just for this execution. Now, the bad news is execute with recompile doesn't really do all of the great optimization things that option recompile does. So I would never use this in production except for testing. So if you're suspecting that that plan is really not as optimal as it could be, you can run these side by side and you can tell, again, the plan shape is different. Did we result in fewer IOs? And sure enough, right, we went from 90,000 down to 925. Now, I want to stress that IOs alone does not make a plan, okay? As you have larger, more complicated plans, you might also want to watch time, because you might find something that has slightly more IOs, but let's say doesn't do a sort, that ends up being faster than something that has fewer IOs, but has to do a sort operation. So things do get more complicated with more complicated plans. But what I'm trying to say is a little bit of additional looking to see if the plans are stable across a bunch of executions will really do you a lot of good. Now, let me show you how this gets really cool. I keep saying you can do this, right? You could do this with another value, right? So 9912, execute with recompile, we go and we look. And the plans actually this time look the same, but if I look at IOs, I can see that they did change. And if I actually drilled into these plans a little bit, it's the index that's being scanned that changes. And the index in the second one is a smaller index. So if I hover over this, I can see the object is the member last name object. Whereas if I scroll here and hover over it, I can see it's the member code object. But again, I don't want to get wrapped up in the plans as much as the easy way for a developer to recognize that their code could be prone to these problems. So all we're looking at right now is maybe time, but time, you know, on fast things is probably not very useful. IOs is often incredibly useful. And then looking at kind of that plan in cache versus our executed plan with recompile can be really useful to get some insight into whether or not something could be done differently. So now we don't really know yet how to fix this and even recognize it perfectly. So I want to go back to the slides for a second, and I want to show you a little bit more on this. What and where we're at right now is a developer that kind of does some testing and everything looks like it's great in development, but what they've done, I promise, won't scale because of these weird kind of behaviors. So, okay. So at this point, yes, data size and data quality definitely matter because they're being led astray by the smaller data sets that they're often working with. Now, even if they're working with a big data set, what you have to remember if it's a test environment is it might not have all of the other users, all of the other activity, all of the other contention and locking and blocking. So they still might get these false positives that what they've written is efficient and it's not. So I still want them to do plan stability, even if they do have better quality data and more of it, like more realistic data. Okay, so we really want to kind of check on these execution characteristics because when plans are bad in production environments, they can be really bad. Like I had a customer once that had one stored procedure that essentially when kind of the wrong plan got into cache and subsequent users started executing that plan, their server would effectively become inaccessible. They didn't know about the dedicated admin connection, so they'd look at each other and they'd be like, Bob, I've changed the names to protect the innocent here, but they'd look at each other and be like, hey, Bob, it's doing that again. Yeah, Joe, you want to hit the switch? And they'd literally fail over their failover cluster. It was an 8 or 16 way with 128 or 256 gig of RAM. I don't even remember. And when this stored procedure got this bad plan in cache, it would effectively make every connection start doing 6 million IOs. And so the system would appear inaccessible. And without the dedicated admin connection, they didn't even know how to troubleshoot it. So they would literally just fail it over and wait until the problem happened again, and then they'd fail it over. And after a few weeks of that, they were like, we better get somebody to help us. Like they had a great idea, but they didn't have a full-time DBA at the time. And so we worked with them, and it literally was one store procedure that was their big problem, but they actually had kind of death by 1,000 cuts with that same pattern in stored procedures that weren't quite as problematic as that one. And even that one, didn't always have the problem, but boy, when it did, the system would basically become inaccessible. So I have to tell you, that's the other thing that's so frustrating about these kinds of problems, is that they're intermittent. They seem to come and go. They might even seem related to something else, and you might do things like update stats or rebuild indexes and kind of get this false positive that that's actually helping you, when in fact that's not really getting to the root cause and really solving the problem. So that's really what I want to stress here. Okay, so this is what's really cool. Now this slide, I'm sure you're looking at this going, what the heck does this slide mean? Okay, so do you remember my little script over here called multi-purpose procedure executions with different parameters? This is my test scenario that I might be using as a developer. Well, I was just, using credit, grabbing the start time, turning things like IOs in time. Well, in this case, I turned time off because it's not super relevant for my machine. But I turn IOs on and I run my different scenarios, okay? So this is just the way that I run this. Well, pardon me. Imagine that I want to see the behavior of what happens as different versions of different plans go into cache. This is super simple, but super cool. Imagine this. I take this highlighted line here, SP recompile, that's commented out. So I have to manually run it, and I do a recompile. Now, recompilation doesn't actually recompile anything. It just marks this procedure's plan as invalid. So the next time I execute, and again, I'm kind of assuming that it's just me in a test environment. So the next time I run this, let's say I run it with test scenario 2 first, or test scenario 3 first, or let me go straight to test scenario 4, because I know this is a particularly bad one. So I run test scenario 4, so the plan for test scenario 4 goes into cache. So then I go back to the top of the script, notice nothing's highlighted, so it's just going to step over that SP recompile and run all these test scenarios with the plan that's associated with test scenario 4. I could then go back, do an SP recompile again, right? I could run a different test scenario, like test scenario 2, run that, and run the whole script. And then what I'm going to do, so this time I've run test scenario 2. Did I actually run that? Yeah, I better make sure. Okay, so I ran test scenario 2, and I go and I run the whole script. So this time I've just run test scenario 2, and all I'm going to do is go over to the messages window and look at the IOs. Okay, 78, 78, 90,000, 90,000, 78. So what I'm going to do is, in a spreadsheet or whatever, I'm going to keep track of what happens to all the other test scenarios just in IOs when I put that plan in cache and run my tests. Okay, so that's what test scenario 2 looks like. If I go back over and I run, well, first we have to recompile. If I recompile and I run test scenario 4, okay, and then I go and I run all of these, okay, and I go at this point to the messages window. Now, if you remember before, it was like 78, 78, 90,000. Now check this out. I have 114, but I also seem to have a work file and a work table. 91,000, a work file and a work table. And this actually has stuff in it, which is not as common unless something spills. So I start looking at this and I track all of these things over. And I start to see that test scenario 4 has a variation in the IOs, and we start to have problems with the workspace that's been given to the temporary objects, because this is doing a hash match. Now, again, they don't have to keep track of the plan stuff or the spilling. Really, just looking at the IOs and looking at them across this whole picture or spreadsheet, you can see where the optimal ones are, kind of across here on the diagonal, right? Where they line up with the tests. I didn't do every single test because like tests 1, 5, and 10 are actually the same IOs across all of them and so forth. But you can see that I have wild variations across all of these executions. So this immediately tells me that the optimal plan varies across all of these executions. So that's really all I have to be able to know, right? And this is where, if your developers have really good test scripts, it actually doesn't take that much to change them to do a further test from code coverage that starts to tell them how stable their plans are across the different saved and cached scenarios. And if you find that the pattern is really consistent, then okay, great, that plan is nice and stable. But when you see something like this, where all the different test scenarios generate, wild variations in the numbers, then it's probably a procedure that shouldn't have its plan saved. And at this point, some people are like, well, what do I do? If I shouldn't save any of my procedures, what do I do? Do I just execute everything with recompile? And I've already told you guys, don't do that. Not only does it not fully optimize, but it doesn't store the procedure in dmexec procedure stats, nor does it store the lines of that procedure in dmexec query stats. So it's harder to troubleshoot, harder to see, harder to find. I only use execute with recompile for testing, okay? Now, SP recompile, which you also saw me use, was kind of cool because if I kick something out of the cache and then I run it again, I get a new plan, right? So that first execution after I've kicked something out of the cache is going to appear to be fixed. But the problem is, right, that might not be the second execution, then the third execution, and the fourth execution. So SP recompile is really just a temporary fix, and I wouldn't even call it a fix at all, right? Now, updating stats really does the same kind of thing as SP recompile. It's just you're doing all the work of updating statistics as well. And at the very end of updating statistics, it usually invalidates the plan. Now, there are some cases where they don't invalidate the plan, but mostly when you update stats, the plan gets invalidated. So then you get a new plan. So again, you're going to get this false positive. Now, some of you have probably heard about adding option recompile to your code. And I have to tell you, okay, this is surprisingly, amazingly awesome, okay? I mean, I'm going to do this. Now, I want you to spend the last 5 minutes with me. I told you guys that I was aiming towards about 65, and I will say that Warwick used 5, so I've still got 7 minutes. That's my story, and I'm sticking to it. But if I go and use credit here, and I turn statistics IO on, just like we've been doing, and we won't even bother with show plan right now. And all I do is I change this procedure to add option recompile at the end. This is all I've done. Okay. I want to go over, well, I'll stay in this group for a second, but if I just try a couple of executions, Tripp, %27, 9912, these are the very first ones I showed you. And if you remember, I had 78, 90,000 and 78 again on these, which actually, to be honest, some of you should have been questioning and probably were. The fact that 9912 member number, which is the clustered index, why the heck was that doing 78 IOs? That's ridiculous, right? It should have never done that. And that is a side effect of having like in my procedure, okay? Because I have like, if you don't have option recompile, this code without the option recompile will be forced into a scan, not necessarily a table scan, but at a minimum, an index scan. So we end up having incredibly poor optimization of this code, even with things like a clustered index. They end up scanning a non-clustered index and then doing the lookups. I mean, it's absolutely terrible. But check this out. Just adding option recompile, I run these three, and I've already done that, and I have 5, 925, and 3. I've never seen those numbers, right? I mean, if we go back to that slide, even when I got the optimal scenario across that diagonal, there is nothing on this slide that's single digits, right? I mean, the lowest we have are those 50s and 78s and 79s, and there's a 114 and a 126 around there, but I am not seeing anything that is 5 or 3, right? So, I mean, adding option recompile, I mean, when I do this, I jokingly say, please do not just go and run out of the room, okay? So I just showed you this. These scale, and that's my little hashtag at the bottom there, they scale to a point, okay? And sometimes they are the best interim fix, okay? And they might actually be the fix for you. If I put option recompile in the entire set of all 14 of my tests, I mean, nothing even goes into 4 digits, right? And in that other scenario, I had numerous that were 90,000 and so forth. So I realize everybody sees option recompile and it becomes the new hammer and every problem is a nail, okay, right? It's like, ooh, just use option recompile, just use option recompile, just use option recompile. And the next thing we know, option recompile is everywhere. And while it might be warranted, truly warranted in a few of those cases, my guess is it just seemed to be the easy, fast, simple solution. And there will be a point for some of you guys where you run into CPU problems. Now, I know most of you are probably going, okay, Kimberly, I have IO problems. I do not have CPU problems. I have tons of CPU headroom. I could probably use option recompile in a whole bunch of places and never see a negative. Okay, I will give that to you. That's probably true. But there will come a time where as your users increase, your data increases, that wasting CPU will become a problem. And I just don't want you to do this. In fact, let me take this one step further. Like, let me just give you a scenario. Imagine you have member number, first name, and last name. I'm simplifying this here just to have 3 parameters. And of course, with 3 parameters, we have 7 possible combinations. And, you know, I've always been told never to type in a demo, and yet here I am doing this. But this is the reason why I chose 3 parameters so that I only had 7 possible combinations. And here's my point. Imagine I had member number or customer number, right? First name and last name, and that's it. If I say select from customers where, you know, first name like %E%, that's terrible, right? I mean, this one, if I have wildcards and I allow leading wildcards, yeah, this one is probably going to need to recompile. But if I say something like where first name like %E% and member number equals 1, 2, 3, 4, 5, right? Then we're going to do a clustered index seek on the member number. And what that actually means, just kind of commenting out, is that this is a nice, stable, reproducible plan, okay? And the point here is, to be honest, anytime we supply member number, that's going to be the case, right? Like, who cares about first name and last name? I'm going to go look up the member number and then see if it matches the other criteria that I've requested. So this is what's cool. I can create, instead of just code that uses option recompile everywhere like I did here, I can write more complicated, uglier code. Okay, so don't get me wrong, your developers will push back at first glance because this looks ugly, it seems more complicated. Everyone that pushed back at first on this comes back to me later and goes, I wish I had known that 10 years ago. Okay, so I promise you, this looks ugly, but it will become kind of the new pattern that you adopt. And what I want you to first do is take all those parameters and at a minimum, build the statement, and I'm going to kind of go through this quickly because it'll take you a little bit of time to read this, but I want you to build the statement with the non-null parameters dynamically. So select blah, 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 where 1 equals 1, so put a dummy where clause into the base of the statement, and then and member number equals the member number we pass in, and last name equals the last name. But do these only when those criteria are provided. So if member number is not null, then we'll tack on the member number clause. So what this actually means, again, because I don't know what it is with 7 or 8 parameters, but with 3 parameters, that means there would be 7 possible statements that would be created, right? There would be one with just member number, one with member number and first name, one with member number and last name, one with member number, last name, and first name, right? And ultimately, those would actually all have the same plan because I'm using equality on member number. So I have a nice, very selective criteria. So my point is at the very end, after I've built the statement, I can add in any of the conditions that you know are stable versus not stable. So the trick was at the very top. Not only do I have my SP executes equal string, but I have a flag. Do I recompile or not? And I might default to recompiling. But if the member number is not null, I'm not going to recompile. Right? If they supply at least 3 characters of the last name and at least 4 characters of the first name, right? So without a wildcard, so like TRI%, KIM%, then maybe I know that that's stable enough that I don't need to recompile there, right? Or if they supply at least 10 characters of an email, that's kind of lame. You'd probably want the whole email or much more than that. But the point is you can add these conditions over time. You could start with just if member number is not null and if email address is not null, and maybe you don't allow wildcards on the email address or whatever, then you say, if we should recompile, then tack on option recompile. So what would happen is they'd have 7, in this case, statements where this one would not have option recompile, but these might, right? This one might or might not, depending on when it's run. If it's run with leading wildcards, then it would go ahead and put option recompile in. But if it's run with at least 3 characters of first name and last name, then it would go and use a cached plan. So this is super cool because it allows you the ability to essentially decide when the plan should be compiled and when the plan should be saved, right? Or I should say recompiled versus saved. And then you just pass this whole thing into SP executes equal, whatever the string is. You can put in all the parameters because even if they're null, this still executes beautifully. You don't have to have a different SP executes equal for the non-null parameters, just one SP executes equal. So I do this, and again, you're going to want to take some time and play around with this, and I'm going to give you guys all this code so you can, right? And you could change this and do whatever you want. But now, as I run through different scenarios, right, and I'll just run these that are in this test, you can see what I did is I am outputting the string that gets generated. So select M from member where 1 is 1 and member number equals. And that's all that I supplied in that one. And notice how that one is not going to get recompiled. I need to find one that will get recompiled. This is a full last name and first name. Here's one with nulls and all of those. So I'm pretty sure this one will get recompiled, but got to scroll. There we go. So look at this one. Email. So email like email, region equals region, member code equals member code, option recompile. So you can end up, especially if you work with the users and like coming back to this, imagine not having this every single option dialogue. What if you have 2 levels to this dialogue? What if you have customer lookup where you give them the option initially of a customer number or a last name and a first name with at least like 5 characters before any wild card? And you put, this is the more optimal way to look up your customers. Please try to get a customer number from the customer or at least the first few characters of their first and last name, and then we can do an efficient lookup. If you can't get this information for whatever reason, click on some other button that you put, on this dialogue that is fuzzy lookup, slower lookup. Like, it's one of these things, and I swear I can't get Cuba Gooding Jr. and Tom Cruise from Jerry Maguire out of my head when I do this, but it's like you're telling the users to help you help them. Right? Like you're having the users do a more efficient search, which in turn is going to end up, if they're mostly searching for customer number and full last names and first names, then they're going to be accessing the cached plans. So even the amount of CPU that you're throwing at recompilation is going to drop, because the nature of the executions might be 80% of the more optimal compiled plans. So this is what's really cool, is thinking about the interaction on, the user's interaction on two different levels. Yes, you want to give them the options, but you also want them to be doing the more optimal things. So if you can get and direct them to the more optimal things, and then have your code do the right thing on the back end, you will end up having a much more scalable environment. So I know option recompile looks amazing, and I know a lot of people want to run out of the room and just change their code and add option recompile. And I would argue that for some of you, this is a phenomenal interim fix. And yes, some of you might actually want to go back to your offices and take one or two stored procedures that have really weird, intermittent performance problems that you've been suspicious about, and maybe add this to see what this does, okay? But I wouldn't leave it as the full-time question, right? Or not the full-time question, but the full-time answer, right? I would make this kind of your Band-Aid fix, and I would go and do what I just showed you, right? You do get huge benefits putting option recompile in, but I would prefer this much more hybrid approach where stable plans are cached and unstable plans are recompiled, so that you don't throw away CPU where you don't have to. And then, right, depending on what your workload is and whether or not you can get the users to do the more efficient thing, you might even be able to improve performance more by just guiding them to the more optimal strategies. So I love this. I ended up doing a little bit more than I was planning to initially. I just love that hybrid approach. I think it's so useful and so effective. And I actually have a whole bunch of resource slides at the end of this slide deck. I have a blog post, because I know some people really are more readers. They want to read the concepts and see the code. So I've got a blog post series. I start with a SQL Skills 101 post, which kind of generally talks about stored procedures. And then it links to the building high performance procedures post, right? And then what you guys might want to do, there's another session. It's similar to this, but I actually did some further demos where I took that stored procedure and ran it, like, I think it was 300,000 times. And once I ran it 300,000 times with option recompile, and it took like 50 seconds. But then I did the hybrid scenario, and it only took 30 seconds. So I shaved off 20 seconds of CPU time out of 50 on something that was run 300,000 times. And I don't know about some of you guys, but I have customers that have some statements and some servers where they're executing 450,000 a second, okay? A lot of them are gambling related, okay? But the point is, when you start talking about the really high end, this really matters, okay? For some of you, it might not matter as much. Option recompile might be a really good interim solution, but as those databases start getting larger, have more users, even that isn't going to scale as well. So this hybrid solution will be a much more balanced approach to kind of dealing with the long-term scalability of your server. So anyway, that past session is another thing that you could go and look at. I've got the Pluralsight courses that you can at least watch for 30 days from Paul for free. I would actually start with the ad hoc statement performance one, only because there I talk about exec versus SP recompile versus, plans of statements in general, plan cache bloat, then stored procedures. I go into conditional logic like if else, and how poorly that can be optimized, and how creating things like sub procedures and actually branching to another procedure is a better strategy, but even then, you might want to do some other things. I talk about not just option recompile, but optimize for unknown and option optimize for. And then I told you guys a little bit about this. Optimizing stored procedure performance part 2 is the one that's about troubleshooting and session settings and seeing all the different session settings of the existing plans in cache and so forth. So there's a ton of content out there. There's a bunch of blog posts. And then I think I even have a couple more hidden slides in there. But there's just so much that's out there that I think in and of itself, that's part of the problem, right? Where do we look? Where do we start? What do we do? Who do we believe? But I promise, if you go through these demos and try some of this stuff out, you'll see what I showed you. And if you then just take one of your nasty stored procedures, because I know you know what they are, like the stored procedures that are almost like swear words in your office, right? We all have them, right? Try this approach on one of those, and you might end up kind of being amazed and coming back to me later and saying, I really wish I knew this 10 years ago. So, but yeah, okay, I'll shut up now. I heard Warwick come back. So thank you, everyone that's saying thank you. You're welcome. You're welcome.
Thank you, Kimberly. Thank you, everybody.
You're welcome.
What a session. So everybody, we still have time. If you do have any questions that you want to put in, we've
yeah, there
got
were a
the
few
time.
that I did see.
So it
yeah,
looks
and
like
Donald, thank you. Control Shift R. I'm actually going to write that down now and like put that on a little post-it on my screen, because I didn't know you could. I mean, I guess I could have looked. I just didn't even think about doing that. But refreshing IntelliSense, because now in my presentations I'm going to say, see the little squiggly? You can refresh IntelliSense. That's awesome. Oh, any tidbits for CRMs? Oh. Brack, I'm really sorry. Do you want to give me any name? Yeah, resources. Hey, and just so you know, Andy, I'm going to bundle up all these. Well, everybody should hear this. I'm going to bundle up all of these slides and make sure that all the links are active and working. And I'll pass all this off to Warwick so he can post all this. So you guys will have access to all these links. All these links will be live in the presentation, so you guys will be able to get all of this. Yeah, Narav, automatic tuning. Well, let me go back to the CRMs for a second. Depending on the CRM system and depending on how they have either generated the code dynamically, because there are some CRMs that have different attributes and different tables and then generate the code dynamically. And in some cases that can be really good. In some cases they go against joins across all of their tables, filtering out only where there's equality, so they get terrible performance across these complicated kind of largely attribute driven systems where different tables have some of the attributes. It's a tough one, but I would tell you that if you are using CRMs, try to work with the vendor to find out if they support things like versioning. Versioning can be a huge, huge beneficial thing to turn on for CRMs, for SharePoint, for a lot of third-party products in general that do bad things. And I hate to say it that way, and I apologize, but when I say do bad things, again, it comes back to they just didn't know how SQL Server would behave with, volume XYZ and their code. And if you do think about things like SharePoint, right, it almost spread like a virus, right? And it's everywhere with different amounts of data, with different workloads, with different patterns. So there was no way that one set of indexes and one set of code was going to be optimal in every scenario. Yeah, and Dynamics, yeah, I was actually wondering if it was Dynamics. There's definitely a lot of dynamic code. In some cases, it is getting recompiled. You want to make sure that they're not forced parameterization. You want to make sure that you're all simple parameterization, like 99.9% of the time. I will leave a database in simple parameterization and not forced parameterization. And if that's new to you or you're unfamiliar, I would almost say don't even learn about forced parameterization, because I don't want you to turn it on. But if you're really desperate to learn about it, I did talk about simple parameterization and forced parameterization in my optimizing statement performance in that Pluralsight course. And the coolest thing I talk about, and you'll have to bear with me, second to last slide. Okay, hold on. The plan cache resources, yeah. Oh, the MSDN article is a little bit dated now, but that's an interesting one too, because Bob talks about things like entity frameworks and stuff like that. But Bob retired now. Oh my gosh, I'm not even sure, 6 or 7 years ago. So that article is pretty old, but it still was interesting. And there's probably better ones now, but ORMs, you know, and CRMs that are dynamically generating code. The big problem that a lot of those have is that they're either over recompiling because they're not saving any of that code if it's a lot of ad hoc. And with CRMs, when they're generating a lot of dynamic code, it's very likely that that's not getting saved where some of it maybe should be cached. And that's where you start using kind of a hybrid of simple parameterization and then plan guides, where you can use what's called a templatized plan guide, where you can take a SQL statement with parameters, but actually tell SQL to force that statement into the cache rather than forcing all statements into cache, because all statements very likely should not be in the cache, but you keep the database in simple and you take one or two of the, let's say, stable statements that have only one plan and you force them into the cache, and you can save a lot of compilation of resources. So that's the question. How do you even know what those are? And there's a cool DMV, I mentioned it in the slide, called DMExec query stats. And you can end up aggregating DMExec query stats by query hash. And you can end up seeing statements that are very commonly in the cache. And then you can see how many plans that query hash has by looking at the query plan hash. That's another column in DMExec query stats. And so, and this is all in that Pluralsight course as well. This is the one I'm talking about here is that first one in the list, optimizing ad hoc statement performance. Because if you're using ORMs or you're using CRMs that generate a lot of code dynamically, you're very likely running into plan cache bloat and scenarios where some of those plans could be saved, which could save you both cache and time. But what you have to do when it's all dynamic is you either have to change the code, which you may not be able to do, obviously, or you can create these templatized plan guides, and you can end up kind of forcing a couple of the stable scenarios into cache so that they're not bloating the cache as much, and they're getting the plan immediately instead of having to recompile, so they're also not wasting CPU. But it's a huge difficult question and problem. So I would say check out optimizing ad hoc statement performance. I would consider versioning, and you did say snapshot isolation has been turned on. So my question there is, there's really two flavors. There's row versioning, and then there's snapshot isolation. So sometimes it's called RCSI. I would actually make sure that that is on even more than snapshot isolation being on, because snapshot isolation is actually only used when code is changed, whereas row versioning or RCSI is actually used by read committed statements with no code changes. So sometimes that has, okay, so row version was turned on. So, okay, so that's one thing, okay? Unfortunately, again, when you can't change the code, you have to rely on things like templatized plan guides for some things. The other things that I would stress would be things like indexes, index maintenance. I know some people are like, oh, we have all solid state, we don't have to worry about index maintenance. That's not true, although I would throw out that solid state would also help you in things like SharePoint and CRMs that have a lot of dynamic code. Because they probably are going to disk a lot. So obviously removing the cost of the random IOs is great, but I still want to stress that you want to do index maintenance, because you still don't want things like splits. You don't want pages that are half full. You don't want to be wasting pages in cache. You want to make sure that you have good maintenance. So unfortunately, when you can't change the code, you are going to rely more on kind of the overall maintenance strategies to improve that environment. But things like row versioning are very useful and usually can help. And what's that one about getting rid of the developers? All I can see right now is getting rid of the developers, which of course would help some problems. Sorry, hold on. I just maximized that window and it disappeared. Where did it go? Oh, it snapped back in. How weird. Oh, that's not maximized. That's a snap. Okay, so the only way you can make this larger is by dragging. Okay. Yeah, okay, so if developers deviate, don't know what data is used to reference, how frequently it's used, they won't be able, yes, the key point is always the same. Yeah, I mean, it is true. There's really, in my opinion, for SQL Server tuning, there's three things. You need to know the data, right? That's one piece of it, but just having the schema isn't enough, right? You have to know how the data is being used, the priorities, the criticality of the data. But the third thing is also the missing link, in my opinion, on SQL Server, and that's you have to know how SQL Server works to a point. I mean, you don't have to know every single thing, but some of these more common things like caching and, you know, statistics and indexing, these things that are so critical to optimization, those are the pieces that when you know your data, know how it works, the workload characteristics, and you know how SQL Server works, you can bring those three things together for phenomenal performance gains. But you're absolutely right. I mean, you can't tune one without knowing the others. And if you know nothing about the data, at least we have things like DMExec procedure stats, which tells us cumulative costs of our procedures on the server, so we can start to see which procedures are cumulatively the most costly. We've got DMExec query stats, which we can then aggregate to see patterns over things like query hash. So there are ways to let the server tell you what workload characteristics are costing you the most, because obviously when a user tells you something is important, they're kind of myopic and they only know what's important to them. So that may not be the best to tune on the server. So, you know, getting the information from the server's workload is hugely beneficial, but you're right. You know, we always need to know the data, know the workload, and then these tidbits about SQL Server's behavior really bring everything together and allow us to, you know, write the most effective code. And yeah, I agree with you. Get rid of developers using no luck. That's a great point, because even if you turn RCSI on, you will override the RCSI versioning behavior with any hints that are in your code. So if your code is filled with no lock, and then you turn RCSI on, you're actually adding overhead for no benefit, because you're going to add the versioning overhead, which will happen on all modifications, but the no-lock users won't use the versions. They'll do the dirty reads. So it's really important to make sure that if you're using RCSI, that your users are in read committed, because no-lock is actually synonymous with read uncommitted. So that's a great point. Let's see. Cost threshold value for parallelism. That's another great one. Almost always people will increase this so that SQL doesn't parallelize as early. But, you know, is parallelism always bad? Is parallelism always good? Is a whole loaded question in and of itself. In the old days, there were lots of bugs around parallelism. There are far fewer bugs. I would generally allow parallelism. I would generally not significantly limit it, things like max stop and so forth. But that's a tough one as to where to start and how to set that. I usually defer to Jonathan Cahias's posts on cost threshold value for I can't even say it at this time of day. But John's on our team, his blog's on SQL Skills, because heck, if you'll be able to spell his last name. But when I put I'm writing a note to myself, when I put the resources together, I'll put a link to a blog post that John's done on cost threshold for parallelism, or just some good resources out there. I would probably argue for a lot of you, especially back to CRMs and ORMs, to look at weight statistics as well. If you end up watching Pluralsight, Paul has not only some blog posts on weight statistics, but also a Pluralsight course on weight statistics, because that's another interesting approach to tuning. It's kind of like, if I look at DM exec procedure stats, I can tell which procedures are the most costly, but another approach, without looking so specifically at things like procedures, is to just find where your server is wasting time, where your server is waiting, right? And if you can find the places where your server is waiting the most, then clear that wait, right? Or fix that issue, and it's like opening the dam, right? And letting the floodgates through. And what's really cool is when you start looking at weight statistics on your server, SQL Skills, and this was spearheaded by Paul and a whole bunch of people in the community, have done all these weight statistics posts on SQL Skills that give you like, oh, you're seeing a lot of this weight statistic, then here's what you should consider troubleshooting, checking, look at this DMV, and so forth. So, I mean, this is the problem though. If you can't change the code, you are really trying to look at, all the other things on the server that you could possibly tweak. And I do have to admit that throwing more hardware, I hate telling people to kill problems with iron, but when you do have a third-party environment that you can't change the code, that would be a great thing. Now, the most important thing that I've done on some third-party applications is I've actually worked with a third-party vendor. I've seen some code, I've seen some poorly written things, and I've been like, ooh, this should really do this. I should have this index. I put the index on, I do some testing with the code, and I find that it's, orders of magnitude faster for my use cases. Now that third-party product might not want that index in every environment, but sometimes when you go back to the third-party vendor and you say, you know what, I had this problem with my workload, I created this index and I had much better performance, some third-party vendors will actually support you with those indexes, or at least allow you to create them. Even Dynamics, if you create a script that drops the indexes you created or recreates any indexes you dropped or disabled, right? As long as you put things back before you install a service pack, they will support you. And I've had so many environments like Dynamics where I've gone through and I've checked usage stats and behaviors, and I've ended up disabling or dropping like hundreds of their indexes and adding, a few dozen of my own, and had way better performance. Now, if the vendor doesn't allow you to create indexes, they don't allow you to change code, they don't allow you to do anything, that's where it gets even harder. And even in those environments, I still can change them in my environment, right? I'll say that I can, as long as when I'm working with the vendor, I can reset it back to how they're expecting it for troubleshooting, right? I can't expect the vendor that doesn't allow changes to troubleshoot my changes. But if I can put it back to how they're expecting it, and I still have the issue or whatever, if the issue goes away, then obviously it was my problem. But if the issue is still there and they troubleshoot, fine. And then after that, I might put back a couple of indexes or even change a procedure here and there. It's frowned upon, it's not supported, but in the end, sometimes it's the only way I can get to something to work. So yeah, sorry, I kind of got on a soapbox there, and I just realized I'm way over. But everything is a GUID. I'm just gonna cry. MacStop is 1, which sucks. Yeah, you guys, it seems like some of the things that these vendors are doing that's not ideal, like no lock everywhere, MacStop 1. At least snapshot isolation and RCSI being turned on can usually be a good thing. But if they then get rid of max degree of parallelism 1, so they get rid of parallelism. They probably did that in an older version because maybe they did hit a few parallelism bugs. So then they're like, oh, we got to turn this off. Going back, especially if it's a smaller vendor, and talking to the vendor about some of this stuff can be, hugely beneficial. But it's slow. It's a slow process, I have to tell you guys. And this is really cool that a bunch of you guys have gotten the mask straps from Paul. He has printed over 14,000, and he actually has an empty queue right now if any of you guys need these. But something that happens with masks, if you don't know about this, is that they can really start to bother your ear because of that, the strap that holds on to the back of your ear. So 3D printers can print these thin mask straps that are quite flexible, and you basically put it on the back of your head, and it holds the strap from the mask better. And actually, some of the coolest scenarios, we've had a couple of people actually at a retirement center where one of the patients or whatever didn't have an ear. So the mask strap is what allowed them to basically wear a mask because they didn't have anything they could put the mask on. And then some other people with turbans and so forth have told us that it's great because they can actually put the mask outside and not have to worry about it interfering. And anyway, so there's just a bunch of cool uses of the mask straps. So hit Paul up. You could look at his blog, look at his Twitter stream, and he's definitely got information about it. And you could Google the mask straps. I'm sure you'll see Paul and Tim. Tim Radney's been printing them. Tim has 4 printers going. It's crazy. But between them, they've printed like 30 or 40,000 of these mask straps, and totally for free. The only thing we ask is for international shipping, that you pay the shipping. But he's printed he's had a couple customers, but he's had a couple of like hospitals that asked for like 800. And it takes a while to print these, but literally 24/7 since March. The printers have been going like 24 hours a day, printing mask straps 8 at a time. And it takes 2.5 hours per 8. And he's got 3 printers going, and Tim's got 4 printers going, and they've gone over 40,000. It's really cool. So it's awesome that a few of you have received those. So if any of you guys need mask straps or know anybody that's, first line responders and stuff, it's really cool because it takes a lot of the stress off their ears. So anyway, okay. I think I got a cue. That's nice. Thank you. You guys are really nice. I do, when I tend to get going, I don't shut up, so I apologize. But this was really fun, and I love when I get questions. You guys had some great questions. I think I got everybody. Okay, edit, IntelliSense, refresh local cache. See, you guys are all way smarter than me because sometimes I just don't even go looking for that stuff. But I love the Control-Shift-R too. But okay, so, and the resources, again, you guys will have all of those. In fact, Warwick, as soon as we're done, I will bundle everything up, get a couple more links, send you a zip. So give me like 10, 15 minutes, but I'll get everything off to you, and then I don't know where it goes from there. So you can do your magic from there.
No problems. So yes, everybody, the session has been being recorded. Once we finish, it will take a little bit of time to work through that session recording. Along with the recording, all of the additional materials will be made available on the DBA Fundamentals archive site. So you'll just be able to go to the DBA Fundamentals, go to the archive, you'll find the particular session, which will be in our second session in September, and that will have a link to the recording, which will be on YouTube, and you will have the ability to download these additional resources.
Awesome. Well, thanks, you guys. Everybody's saying thank you now. You're welcome. These are great fun. I always get nervous before I do any presentations, but once I get into it and start getting questions and interacting and stuff, it's like a high for me too. So I really enjoy it. I still love working with SQL Server after, I can't even believe it's been 30 years, 25 years with SQL skills. I was with Microsoft before that, and actually IBM before that. So, yeah, but I started working in the industry when I was 2, so I'm actually only like 32. That's where Paul, if he were here, he would go, I wish that his wife was only 32. But anyway, oh, okay, I digress. Now I'm telling you too much. Have I told you guys that we have 7 cats? We're kind of crazy cat people. That's my last thing. That should be the last part of the recording. Paul and Kimberly are crazy cat people.
All right.
Oh, now even Warwick's laughing.
I've been smiling all session.
Oh, thank you. Oh,
Well,
and scuba diving. I
yes.
know. Don't even start me on that. Oh, did I lose you? What happened?
No, it just went quiet. That's okay.
Oh.
So thank you once again, Kimberly, for your time this afternoon. Fantastic session. Thank you, everybody, for joining us for this session. Make sure that you register, and I look forward to seeing you all online for the next session in 3 weeks' time. Everybody, stay safe. Have a good afternoon, good evening, good morning, wherever you are. We'll see you again soon. Thanks, everybody.
Thank you.